Lattice enthalpy values can be obtained from Born-Haber cycles and by calculations based on the perfect ionic model. Which compound shows the greatest percentage difference between these two values? So the perfect ionic model assumes that they're perfect spheres. And for them to be perfect spheres, we want the positive ion to be small and the negative ion to be small. We don't want these two things to be distorting each other. Now, the smaller the positive ion and the bigger the negative ion, the more this distortion is going to start to happen. So the higher the charge density of the positive ion and the bigger the negative ion, the more distortion is going to happen. So we've got really to compare cesium with lithium and then fluorine with iodine. So we look on the periodic table at them. So cesium is much bigger than lithium. Okay, so cesium is it's got a lower charge density, going to be less good at distorting ions. So I don't think we're going to pick one of these cesium ones. We want to pick one of these lithium ones. Lithium's got a higher charge density. And then out of the fluoride ion and the iodide ion, who's going to be most easily distorted? The iodide ion is much bigger, so lithium iodide is going to be the most distorted. Lithium has got the higher charge density of the metals, got the most power to distort, and iodide ions are bigger, so most easily distorted. That's going to be the least like the perfect ionic model value.